Although it may never take the crown for the most terrifying exoplanet in the verse, that title goes to WASP-12b, a super-hot Jupiter where it likely rains diamonds. WASP-107b is making some waves in scientific circles for a very different reason. Curiously, WASP-107b is thought to be a hot Jupiter, but because its core mass is far less than what we see in gas giants like Jupiter and Saturn in our solar system, scientists are starting to reconsider the mechanics and requirements for when gas giants form. But wait, there's more. WASP-107b may be an entirely new type of planet. We're going to dive into what that might mean, but first be sure to hit that like button, let me know your favorite thing about exoplanets in the comments, check out the Patreon in the description, smash that subscribe button, and ring that bell to never miss a video. I'm Eric Malachite, author of Echoes of Olympus Mons, and this is ScienceGet. Orbiting a star 212 light-years from Earth, WASP-107b exhibits some surprising characteristics. For one, it's just as large as Jupiter, but seems to be around 10 times lighter. It also just so happens to orbit 16 times closer to its host star than Earth does. This presents some challenges for astronomers, as the planet appears to weigh in at just under Neptune's mass. In fact, the exoplanet is one of the lightest ever discovered, leading astrophysicists to call it a super puff or cotton candy planet. Professor Bjorn Bennecke, a member of the groundbreaking research team at UDEM Astrophysics, had this to say about the discovery. This work addresses the very foundations of how giant planets can form and grow. It provides concrete proof that massive accretion of a gas envelope can be triggered for cores that are much less massive than previously thought. Caroline Pialet, the PhD student who made the initial discovery, and her team analyzed the data surrounding WASP-107b to determine what its internal structure could be, and even they were surprised by the conclusion that they reached. Since 2017, when the exoplanet was first discovered, Pialet's team has used the radial velocity method to calculate the mass of the so-called superpuff planet. This method is typically used to detect exoplanets orbiting around M-type red dwarf stars, because generally low-mass stars are more affected by the gravitational pull of the planets orbiting them. Now, her team believes that WASP-107b must have a solid core which is at least 4 times more massive than the Earth. Now, WASP-107 is not an M-type star, but a K-type, otherwise known as an orange dwarf. These stars are categorized one level below stars like our own, ours being known as a G2V type, meaning that it is one of the brightest types of yellow G-class stars, and also a dwarf or main sequence star. But the radial velocity technique is also used for placing accurate constraints on a planet's mass, allowing astronomers to determine the inclination of the planet's mass and also narrow down an accurate figure for its mass. And after taking these measurements, Pialet's team came to a startling realization. The core of WASP-107b had to have been solid, and it had to have been at least 4 times more massive than the Earth. This also means that as much as 85% of its mass has to be contained within the thick layers of gas that surround the core. To put this in perspective, Neptune's gas layer only contains 5 to 15% of its total mass. Now, obviously this raises some huge questions about how this planet was able to form, and how it was able to hold onto the gases in its atmosphere. But thankfully, Pialet's team weren't ready to call it quits just yet. Current theory suggests that planets form from a protoplanetary disk that orbits a young star, and as such, the classical model for gas giant formation is based on Jupiter and Saturn, though this has in recent years been called into question thanks to the overabundance of hot Jupiters floating out in the stellar wilds. Before this superpuff planet was discovered, we thought that a gas giant could not form unless a forming protoplanet had at least 10 times the mass of the Earth. Without that mass, it was generally accepted that the would-be gas giant wouldn't be able to build up and maintain the thick layers of gas that we see surrounding Jupiter and Saturn's metallic hydrogen layer. Additionally, if you remember what the Juno spacecraft discovered about Jupiter, you'll know that it doesn't have a solid core, and in fact part of it has dissolved, appearing to almost be impacted like something hit it, which scientists think actually happened in its recent cosmic history. Jupiter is 90% hydrogen 1, 10% helium, with some other elements thrown in for good measure, and Saturn is thought to have a similar, much smaller core, though as far as I know it hasn't been directly measured yet through instrumentation. Before Juno, the jury was out on whether or not Jupiter and Saturn had solid cores. Remember that planets like Neptune and Uranus are not the same as gas giants, as they're much closer in size to terrestrial planets like the Earth. For example, Neptune is 4 times the size of the Earth, while Jupiter is 318 times larger. It's a big difference. We're not entirely certain if other gas giants follow the same rules as the ones we observed in our own solar backyard, but if they did, how then is it possible that WASP-107b, which is thought to have a solid core, was able to form given its reduced mass? Well, Eve Lee, an expert on superpuff planets, explains, for WASP-107b, the most plausible scenario is that the planet formed far away from the star, where the gas in the disk is cold enough that gas accretion can occur very quickly. The planet was later able to migrate to its current position, either through interactions with the disk or with other planets in the system. But while this may be a plausible scenario for how WASP-107b formed, another surprise was in store for the teams around the world who had been watching the system, and that was a new planet. WASP-107c is particularly interesting because it has about 1/3 the mass of Jupiter, which is still quite a bit more than our superpuff buddy that's attempting to hug its star. And it's also much further from the star, with an orbital period of 3 Earth years. Its orbit is also highly eccentric, making it more of an oval than a circle. Piolets suggests that this must mean that WASP-107c contains many of the secrets of the system's early formation, and those secrets might be tied to its extreme eccentricity, meaning that the WASP-107 system must have had quite the turbulent past, featuring significant displacement events like the one she suspects led to WASP-107b being in the precarious position it's currently in. There are, of course, many other mysteries surrounding WASP-107b. For one, it doesn't contain much methane, which Piolet suggests is strange because one of the prevailing ideas behind planets like WASP-107b is that methane would have to be abundant. The current theory is that the planet used to have abundant methane, but somehow through its formation and history, that methane was destroyed. Piolet suggests that scientists like her and her team will have to go back to Hubble's observations of the superpuff planet and use the new mass of the planet to see if it affects the results and to see if their theory that the planet's methane was somehow lost holds any water. Or, gas. Yeah. But exoplanets like WASP-107b are truly strange because there's no comparison to any of the worlds in our solar system. On one hand, this is good because it allows us to better understand the mechanics behind planetary formation. And on the other, it runs the risk of confusing the hell out of people. But that's science. But Caroline Piolet and researchers like her are fired up to study these worlds in even greater detail. Once the James Webb Telescope comes online, her team and others around the world will be able to see these exoplanets in even greater detail, which is more than likely to bring about some insane revelations in our understanding of how these worlds form, as well as deepening our understanding of the universe. I'm all for that. If you enjoyed this content, be sure to drop a like and comment your favorite thing about exoplanets. And be sure to smash that subscribe button, ring that bell to never miss an episode of Science Get, and check out the Patreon, where you can get early access to Science Get episodes, science fiction, horror, and dark fantasy short stories, your name in the credits, and so much more. I'm Eric Malachite, and I'll see you next time.